A lot of people think Earth is hanging in space because some force is holding it up. But in space, there's basically no up or down, no left or right either. And there isn't even a place for anything to fall down to. In a sense, the phrase falling down is a lie, one Earth has been selling you for decades. Out in the universe, there's no floor. You could travel in any direction for billions of light years and never hit a wall. So here's the real question. If there is no down, why doesn't Earth just drift away? Why does it obediently orbit the sun instead? The answer is more terrifying than you think. Because the sun is digging an invisible hole beneath Earth. Earth isn't hanging there at all. It's violently swirling inside that hole. It's been spinning in it for 4.6 billion years, and it still hasn't escaped. That hole is called the curvature of spacetime, discovered by Einstein, and how deep it is directly determines whether Earth survives. You might ask, how can spacetime be dug into a hole like that? Isn't space supposed to be empty? This is where Einstein gets even crazier than Newton. More than 300 years ago, Newton discovered the law of universal gravitation. Legend says it happened after an apple hit him on the head, and it made him wonder, why does the apple fall to the ground instead of flying up into the sky? His answer was, because Earth's gravity pulls the apple downward. But Newton never told us what gravity actually is. Why can it pass through air, pass through vacuum, cross hundreds of millions of kilometers, and still pull objects toward each other? That mystery tortured scientists for more than 200 years. It wasn't until 1915 that Einstein introduced general relativity. He said gravity doesn't truly exist as a force at all. You didn't hear that wrong. The force that makes an apple fall, and the force that keeps Earth circling the sun, isn't a force in the usual sense. It's an illusion created when space-time is warped. So how do you understand that idea? Imagine you stretch a bedsheet tight and place a heavy iron ball in the middle. The sheet will sag downward like a dent. How deep that dent is depends on how heavy the iron ball is. Now place a glass marble on the same sheet. The marble won't stay where you put it. It will roll along the slope of the dent toward the iron ball. But if the marble has enough sideways speed, it won't roll straight in. Instead, it will circle around the iron ball. That's the relationship between Earth and the sun. The sun's mass is about 330,000 times Earth's, so it creates a massive dent in the space-time around it. Earth is like that glass marble, sliding along the curved surface. We call that sliding motion an orbit. So Earth isn't being pulled by the sun. It's moving through curved space-time, following what it thinks is a straight path. But in curved space, a straight path can loop into a circle. It sounds absurd, but in 1919, the British astronomer Arthur Eddington used a solar eclipse to test it. He found that starlight passing near the sun was deflected from its straight-line path. If space-time were flat, light couldn't bend. But the light really did bend, showing that space-time near the sun is curved. Einstein was right. Space-time really can be curved. And what we call gravity is just the visible effect of that curvature. So the next question is, if Earth is constantly sliding toward the sun, why doesn't it fall into the sun? The answer is that Earth has sideways speed. Remember the marble on the bedsheet? If the marble has no sideways speed, it rolls straight into the dent made by the iron ball. But if it has enough sideways speed, it circles the iron ball and never actually falls in. Right now, Earth orbits the sun at about 29.8 kilometers per second. What does that mean? A bullet travels at roughly 1 kilometer per second. So Earth's orbital speed is about 30 times faster than a bullet.
At that speed, you could circle the entire Earth in just 7 minutes. It's that speed that keeps Earth sliding along the sun's space-time dip without falling into it. So what if Earth suddenly stopped? The answer is horrifying. About 65 days later, Earth would crash straight into the sun. But before that happened, everything on Earth would be boiled away by the sun's extreme heat. But don't worry, that won't happen. Because in space, there's nothing that can make Earth break. Space is an almost perfect vacuum. There's no air, no friction, and no force to slow Earth down. The speed Earth gained 4.6 billion years ago has barely decreased even to this day. It will keep moving like this until the sun eventually fades out. At this point, you might ask, where did Earth's original speed come from? To answer that, we have to go back to the birth of the solar system. About 4.6 billion years ago, somewhere in the Milky Way, there was a massive cloud of gas and dust. We call it the primordial nebula.
That nebula began to collapse under its own gravity, and at the same time, it began to spin. Why did it spin? Because matter in the universe already carried angular momentum from the start. This is a physical law called conservation of angular momentum. Simply put, once something starts spinning, it's very hard to stop. It's like a figure skater. When they pull their arms in, they spin faster. The primordial nebula did the same thing. As it collapsed, its rotation sped up more and more. Eventually, the sun formed at the center, and the debris around it formed the planets, including Earth. Earth inherited the nebula's rotation, which means it was already moving on its own. That's where Earth's speed comes from. Nobody pushed it. It has been moving since the moment it was born. But speed alone isn't enough. Earth has been able to run stably for 4.6 billion years because it and the sun reached a delicate balance. If Earth moved too fast, it would break free from the sun's grip, fly deep into space, become a wandering planet, and eventually die in cold and darkness. If Earth moved too slowly, it would be swallowed by the sun's space-time hole, fall into the sun, and turn into fire. Only when the speed is just right does Earth neither fly away nor fall in. It can orbit the sun steadily. So where did that just right speed come from? The cruel answer is that the universe selected it when the solar system was first forming. Back then, there were countless fragments and asteroids around. The ones that were too fast flew away. The ones that were too slow fell into the sun. Only those with a moderate, balanced speed could survive. And Earth is one of the survivors of that brutal filtering process. More than 300 years ago, Newton described the same idea with a famous thought experiment. He imagined placing a cannon on a very high mountain and firing a cannonball toward the horizon. If the cannonball is slow, it follows an arc and falls back to the ground. If it's a little faster, the arc becomes longer. And if the speed reaches 7.9 kilometers per second, the ball's path matches the curvature of Earth. In other words, the cannonball keeps falling, but it never hits the ground. Because Earth is round. While the cannonball falls, the ground is curving away beneath it. So the ball never catches up to the surface, it ends up circling Earth. That's the origin of first cosmic velocity, and it's also the principle behind Earth orbiting the sun. At roughly 30 kilometers per second, Earth is constantly falling under the sun's gravity. But at the same time, it's also moving sideways. As a result, Earth will never actually fall into the sun. In a way, Earth is still falling. It's just that the direction of its fall is constantly changing. Over time, that creates an ellipse. And this elliptical orbit is extremely stable. Scientists have calculated Earth's orbital eccentricity at only 0.017, which is almost a perfect circle. But that stability isn't permanent. In reality, Earth is slowly moving away from the Sun by about 1.5 centimeters per year. The reason is complicated, mainly involving the Sun's mass loss and tidal effects. But don't worry, at that rate, even after 100 million years, Earth would only be about 1,500 kilometers farther from the Sun. That would barely affect Earth's temperature. What we really should worry about is the Sun's lifespan. In about 5 billion years, the Sun will enter its red giant phase. It will expand to more than 200 times its current size, swallowing Mercury and Venus. Even if Earth isn't swallowed directly, it would still be baked into a scorched wasteland. By then, even if Earth is still orbiting the Sun, it won't be suitable for life anymore. Of course, that's a problem for 5 billion years from now. The question we need to focus on right now is different. Why don't we feel all this motion? Think about it. Earth is racing through space at about 30 kilometers per second. At the same time, it spins once every day. At the equator, that rotation speed is about 465 meters per second. So why don't we feel anything at all? The reason is that we're moving along with Earth, and that motion is steady. Think about what it feels like on a train or an airplane. When the vehicle is moving at a constant speed, you can walk around and barely feel like you're moving at all. You only feel motion when it speeds up or slows down. That's when you feel yourself pushed back or pitched forward. Earth is the same way. Both its rotation and its orbit around the Sun are steady, with almost no noticeable acceleration. So we don't feel them. And there's more. Everything on Earth moves together. Air, water, mountains, rivers, and us. We don't have a perfectly still reference point, so it's even harder to sense the motion. In short, Earth can seem to float in space without falling, not because some mysterious force is holding it up, but because of 3 reasons. First, in the universe, there is no up or down, so the very idea of falling doesn't really exist. Second, the Sun's mass curves the space-time around it, and Earth moves within that curved space-time, so its path naturally becomes an orbit. Third, Earth has enough sideways speed, so it's being drawn toward the Sun while also constantly moving sideways, which creates a stable orbit. This system has been running for 4.6 billion years, and it will keep running until the Sun burns its last energy. We humans are still living on this high-speed planet. Everyone is moving through space at tremendous speed without even noticing. It isn't magic, it's just the laws of physics. But those cold, indifferent laws are exactly what gave us a warm home and the chance to look up at the stars and wonder about the mysteries of the universe. Maybe that's the real miracle.